Hello everyone, my name is Julia and today I would like to talk about the integral of secant x cubed dx. So first I would like to break this down into two parts. So secant x and secant x squared dx. So now I would like to set this aside and use the derivative of fg. So we know that the derivative of fg using the product rule is f prime g plus fg prime. So now if we subtract fg prime on both sides, then we would get f prime g from here equal to fg and minus fg prime. And now if we take the integral on both sides, then we would get the integral of f prime g equals fg, because the integral and the derivative can cancel out, and minus the integral of fg prime. So now we can use this formula that we just found to calculate the integral of secant x times secant x squared dx. Now I would like to set f prime equal to secant x squared. So f prime is secant x squared, and now I would also like to set g equal to secant x. So g is secant x, and now that we found f prime and g, we can find what f and g prime is. To find f, we would have to take the derivative, the integral of secant x squared, which is tangent x. And to find a g prime, we would have to take the derivative of secant x, which is secant x times tangent x. So now that we've found all of these, we can just substitute everything back into here. So this is equal to f times g, and f is tangent x. G is secant x, and minus the integral of f times g prime, and f is tangent x. G prime is secant x tangent x dx. And now I would like to multiply these two together to simplify it more. Minus the integral of tangent x squared times secant x dx. So now I would like to change the tangent x squared using the identities of tangent and secant x. So if you already know this formula, tangent x squared plus 1 equals secant x squared, then that's great. But if you haven't memorized it yet, then I will show you how I like to memorize it. So I first write sine over here, cosine over here, and tangent over here, with the 1 in the middle. So now I would like to write the reciprocal of each of these three things across from each other. So the reciprocal of tangent x is cotangent x. The reciprocal of sine x is cosecant x. And the reciprocal of cosine x is secant x. So now we'll be able to create 3 different triangles. Here's 1, here's 2, here's 3. So how can we use this diagram to find identities? Well, here's an example triangle. So if we have A here, B here, and C here, then A squared plus B squared will always be equal to C squared. So like in this triangle, A is equal to sine x, B is equal to cosine x, and C is, of course, 1. And so like sine, it would be sine x squared since the A is being squared. The same for the cosine, and the same for the 1. And it's squared, but 1 squared is just 1. And then for the second triangle, it would be tangent x squared, since A is tangent, and 1 because the B is 1 and 1 squared is just 1. And this is equal to secant x squared, since the C in this triangle is secant x. And finally, on the third triangle, the A is 1, and so 1 plus B, which is cotangent x here, so cotangent x squared equals cosecant x, because that's C, cosecant x squared. And in this case, we're trying to change the tangent x squared, which means that we're going to have to use this formula in the middle. Now, if we subtract 1 on each side, then we would get tangent x squared equals secant x squared minus 1. So now I would like to just substitute this part into tangent x squared here. And so this is equal to tangent x times secant x minus the integral of tangent x squared, which is secant x squared minus 1 times secant x dx. So now I would like to multiply these two to simplify this equation more. So tangent x times secant x minus the integral of secant x cubed minus secant x dx. So now at this point, I would actually like to separate these two, so we would have 2 different integrals. So tangent x times secant x minus the integral of secant x cubed dx, and then we would have a positive sign instead of negative sign, since we already have a negative sign here, and 2 negative signs cancel out and turn into a positive sign. So plus the integral of secant x dx. And now you may recognize the integral of secant x cubed dx because that's actually the original problem that we've been trying to solve for. And so if we just add the integral of secant x cubed dx on each side, then we would get 2 times the integral of secant x cubed dx, which is equal to tangent x times secant x plus the integral of secant x dx. So now finally we can divide 2 on each side. So now we would just have to calculate the integral of secant x dx. So the last equation that we had was integral of secant x cubed dx equals 1/2 times tangent x times secant x plus the integral of secant x dx. And I will be explaining how to calculate this part. So first, what we'll want to do is change the secant part, the secant x part. So we know that secant x is equal to 1 over cosine x. And if we multiply cosine x on top and bottom, then we would get the integral of cosine x over cosine x squared dx. And now, using the identities of cosine and sine x, we can know that the cosine x squared is equal to 1 minus sine x squared. So I'll write that down here. So the integral of cosine x over 1 minus sine squared dx. And now from this point, I'm going to use the U substitute rule to finish it. So I think the best way to do this is by setting u equal to sine x. And then the du would be cosine x dx. So now we can replace the cosine x and the dx with du. So we would get an integral of 1 over 1 minus u squared du, since the sign is u. And now, and by putting that aside, I would like to explain how to simplify this part more. Well, first, it would be easier to factor the denominator. So we would get this. And now I would like to show you how to simplify this part more. So what we would want to do is separate this part into like 2 fractions. So like this is an example. We could turn this into 1 over 1 plus u plus 1 over 1 minus u, but this is just an example. And the reason we would want to change this part into something like this is because, so if we want to integrate it, then we can just do L and absolute value of 1 plus u minus ln absolute value of 1 minus u, like that. But if we wanted to integrate this, just this, without changing it to like this, then everything would get like complicating. And so what I would like to do is change it into two fractions, like I showed you guys. So I would like to start with 1 over 1 plus u plus 1 over 1 minus u. Now we don't know that these two are the same and they're equal to each other, and they're probably not. And so we're probably going to have to like multiply this with something to get to here, but we don't know what that is, and so that's why we're going to try to get from here to there. So if we multiply 1 minus u on top and bottom for this fraction, then we would get 1 minus u over 1 plus u times 1 minus u. And then for this fraction, we would have to multiply 1 plus u on top and bottom. So 1 plus u over 1 plus u times 1 minus u. So since we have u minus u, it can cancel out. And since we have 1 plus 1, the numerator would get to 2. The denominator stays the same. And now, as you can see, what we just got is pretty similar to what we already had, except we have a 2 multiplied on the top. And so to get from here to there, we would have to multiply 1/2 or divide it by 2, which means that these two aren't the same, so we would have to multiply 1/2 here too, so these will be the same. And we would also have to multiply this by 1/2, so these two are the same. And so what we actually got is this is equal to this. So now we can just substitute this back into here. So replace this with that, and that will get us to 1/2 integral. And we can just put the 1/2 in the front. 1 over 1 plus u plus 1 over 1 minus u and du. And now we can just take the integral, and that would be ln absolute value of 1 plus u minus ln absolute value of 1 minus u. And finally, we can just substitute the u back in, and the u is sine x. The u is sine x, so that will get us to 1/2 times ln 1 plus sine x minus ln absolute value of 1 minus sine x. Now, we can use the property of logarithms to simplify this part more. And since we have a negative here, it would turn into a fraction, right? So 1/2 times ln absolute value of 1 plus sine x divided by 1 minus sine x absolute value in parentheses. And now we got the value of absolute value of secant x dx. And now we can just replace the absolute value of secant x dx with what we just got. So let me just erase part. And so we replace it, which will get us to 1/2 times tangent x times secant x plus 1/2 times ln absolute value of 1 plus sine x over 1 minus sine x and parentheses, another parentheses. And now this can be your final answer. But usually in textbooks, for the answer writes it everything in terms of tangent x and secant x, and there's no like sine x. And so I'll teach you guys how you can change this part so it will be in terms of tangent and secant x. So 1 plus sine x over 1 minus sine x. So how the first step we'll do is by multiplying the conjugate of the denominator on the top and bottom. So the conjugate of the denominator is 1 plus sine x. We'll also have to multiply it on the top as well, so we don't actually change the value of the fraction. And now the top will give us 1 plus sine x and square that. And on the bottom, this is equal to, if you expand it, you get 1 minus sine x squared. And now, if we use the identities of sine x and cosine x again, we would get this as cosine x squared. So we can just replace this with cosine x squared, and so we would get 1 plus sine x squared over cosine x squared. And to make things more simpler, we can just change it so that this whole thing is squared, like so. And now we can separate this fraction into two different fractions. So 1 over cosine x and sine x over cosine x. Now 1 over cosine x is equal to secant x. Secant x. And sine x over cosine x is equal to tangent x. And square the whole thing. And now it got a lot simpler. So I'll just substitute what we just got. I'll substitute what we just got into here. So now we have 1/2 times tangent x times secant x plus 1/2 times ln secant x plus tangent x and square. And also we can simplify this part even more using the properties of logarithm. So this 2 can be brought down to here, which will give us 2 over 2, which is 1, so we can just cancel these two out. And for the final answer of the integral of secant x cubed dx, we would get 1/2 times tangent x and secant x plus ln secant x plus tangent x. And actually, these are supposed to be in absolute values. And this is the final answer. Thank you for watching, and goodbye.